Hot dang. I've always wanted one of those cubes from Portal as like a table or something, but I don't think IKEA sells them, so I might be out of luck.
Wait a second. In my previous video, this guy has a cube right there. All I have to do is take it from him, which should be pretty easy.
So I'm making energetic cubes.
Okay, boom. Yes, it worked. Okay, video's over, guys. Thanks for watching.
No, you don't.
Wait a second.
Yeah, it's mine.
Wait,
Haha, yeah.
what do you do?
Well, at least I know it's possible, and more importantly, it's possible for me to do it. So all I have to do now is make it, right? You know, I'm really happy with how that turned out, actually. I made a few creative decisions that I really think improved the design from what the original designers had intended, like using these beautiful warm colors. If I'm being completely honest though, I think I can do a little bit better. Let's just install some CAD software and... I don't know CAD.
Well, that's not something a little software can't fix. We're strapped into the matrix.
I know CAD Fu. Alright, let's 3D model some stuff. I started by modeling these face quadrants using the same thickness as the wood that I had. I'll laser cut these to make some quick flat faces. Here's the laser cut profile. I also left some holes for M3 screws so that I can screw on the wood corner and edge pieces. This hole will be for a black ring that creates a transition between a glowing disc and these wood pieces. I'm also not using any kind of structural component like metal or aluminum brackets like Mr. Volt did. So these screws are going to be load bearing. Don't sit on it. I then modeled the corner and edge pieces, which give that cube the iconic aperture look. These aren't based off of game models or anything. I just used a single reference image and kind of eyeballed it. So it won't be perfectly accurate, but it looks close enough. I started virtually assembling everything, including the black transition ring, the acrylic disc, and this electronics control box. I also constrained all the edges to make sure that the screw holes lined up properly. I'm not really sure why Inventor makes this noise when you constrain an assembly, but it makes me laugh every time. Like, what the fuck? I also set up the print job. I also tried to optimize the amount of filaments that went into this because it uses quite a lot. With this virtual model done, the design work is pretty much over. Now I just have to start actually building the thing. For starters, I have to commune with the machinery. This is actually a really simple process. I'll walk you through it right now.
In the name of the stepper, the driver, and the unholy proprietary control software. Oh, Randall, keep my word.
You hear that noise? That means the printer's done. I love the smell of ABS fumes. While that's reprinting, I brought all the wood pieces outside to sand, prime, and paint them. I really wanted to get this lunar gray paint because of the whole, but it was glossy and I needed something matte to match the style of the cube. I also lasered out these cool Aperture logo stencils for the circular parts, which worked surprisingly well. Doing all this really makes me wish science is a real thing instead of a mental illness.
Hey, nice one. Although I am going to need at least 14 more of those, so good luck.
Hey, the cube looks like it's coming together pretty nicely. There's just one more thing I have to figure out. That being the glowing disc in the center. I've had the general idea of using LEDs to create the different color glows that we see in-game. But aside from the electronics, I don't really know what the best way to diffuse that light would be. Bare LEDs look really crap when you look directly at them, so most products that use them have some kind of diffuser that spreads the light so that you're not looking at hot spots. I decided on using acrylic as my generic transparent material and then frosting it somehow to smear the light around. Putting the frosting aside, I need to find a way to take the acrylic and turn it into a useful shape. My first thought was the laser because that's pretty much designed for turning flat things into differently shaped flat things. There's one small problem with that though. My laser is what's called a diode laser, which means it operates in the visible light spectrum. Now to show you why that's a problem, let's take a look at a little bit of acrylic. If we do the math, we can perform a proof by it's fucking obvious and see that the acrylic is see-through. Also known as, the laser just passes right through it and doesn't heat it up. Why is that a problem? Because the only reason the laser works at all is because it heats stuff up. Now there are lasers that actually can cut acrylic, called CO2 lasers, but I don't have one of these. Stuck with no other options, I decided to do the impossible. I looked it up on Google and found a disc, just so happened to be the exact same size that I needed on Amazon. And now I have some machined acrylic. Frosting time. Sanding acrylic by hand can be a good way to frost it, but I wanted it to be a really even frost, so I used an orbital sander. This ended up working so well you might confuse it for a whole ass job. Okay, just one more thing to take care of before the cube is done. Electronics! The cube is going to have lights inside it, and I need a way to control those lights, make them brighter, dimmer, different colors. I picked out these RGBW LED strips that include an extra white LED to make the white light it produces a much higher quality. The way these strips work is you pass 12 volts into this common 12 volts pin, and then you pull whichever color you want to ground, and it will activate that series of LEDs by completing the circuit. Controlling LED brightness is a little bit tricky. You need to do something called pulse width modulation, or PWM. PWM is essentially turning the LED on and off really fast. Really fast. So fast that you can't even tell that it's turning on and off. Think of a computer fan like this one. Once it's spinning up at a certain speed, you can't even see the blades anymore. You kind of just see a circle. It just so happens, in our case, we can also use this to make the LEDs appear as though they're dimming. To produce a dimming effect, all we have to do is change the ratio of time spent on versus time spent off. To put this to use, I designed a PCB where an Arduino controls a high current MOSFET. The MOSFET just connects one of the LED pins to ground. There's one MOSFET per channel and an auxiliary one in case I want to power something else. Slap on some cool 7-segment readouts and write some code to control these rotary encoders to control the brightness, and we have a working electronics control system. I then soldered some wires to the ends of the strips so that I can plug them in. That task is definitely what I'm going to do in hell forever. And with that, I can create a nice cable management system where the control signals go out and then get distributed to every single face independently. The first version was better.